Good day, everyone. Our topic for today is all about the Sun and the Earth-Moon system. Before we start our lessons, I will read the objective first. So at the end of our lesson, students will be able to describe the rules and characteristics of the Sun, Earth, and Moon in the Sun, Earth, Moon system. Illustrate the position of the Sun, Earth, and Moon during the rotation, revolution, and phases of the Moon. Then show curiosity and interest in exploring natural phenomena related to the Sun-Earth-Moon system, and lastly demonstrate appreciation for the natural order of celestial bodies and by valuing accurate scientific information. And without further ado, let's start.
So before we proceed to our discussion, let's have an activity first. So this activity is called station activity. So I will be demonstrating 4 station, and after observing, write a quick observation per station. So first, let's have rotation station. So sa rotation station is we only observe day and night. So for example, this is the Earth and this is the Sun. That's rotation station. The next is the revolution station. So, for example, this is the Earth, and this is the Sun, or this is the Sun, and this is the Earth. So the Earth rotates around the Sun, or revolves around the Sun. Since I don't have illustration here, so I will be showing you picture. So next is the moon station or the moon pieces. So this one. Kindly observe. The next, lastly, is the tide station. So I have also a picture here. This one. So please write your observation. And good day everyone. I am Joy Harry B. Ilimino from Group 3, and I will be discussing the Sun and the Earth-Moon system. So the solar system is composed of Sun, planets, their satellite, dwarf planets, and countless small objects like asteroids and comets. Observation of these celestial objects reveal their movements, such as the Sun rising in the east and setting in the west, or changing positions of stars throughout the year. Early astronomers believed that the sky moved while the Earth is stationary. In 1543, Nicholas Copernicus proposed a revolutionary idea, which is the Earth and the other planets revolve around the Sun and the Earth rotates on its axis. Okay, next, let's go to positions of and movements of Earth. So Earth rotates on its axis once approximately every 24 hours. From the North Pole, it spins counterclockwise. These rotations causes the Sun, Moon, stars to appear as if they move across the sky from the east to west. The perception of sunrise and sunset at different times and the duration of daylight varies depending on the season and latitude. Next is the Earth's day and night. So Earth's rotation leads to 24 hours cycle of the day and night. So the side facing the Sun experience sunlight, while the opposite experience nighttime. So for example, if this is the Sun and this is the Earth, so if the sunlight directs to this side, they can experience daytime, and on the other side, this side, they can experience nighttime. So lastly is the Earth's season. So seasons are caused by the 23.5 degrees tilt of the Earth's axis and its revolution around the Sun, not by Earth's distance from the Sun. This tilt means one hemisphere receives more direct sunlight than the other, creating warmer or cooler season. So first, we have summer or the northern hemisphere summer. So North Pole tilts toward the sun. Sunlight is more direct and days are longer. For example, this is the Earth and this is the sun. If the sun light is towards the North Pole or directs to the North Pole, so the days are longer. So next we have northern hemisphere winter. So North Pole tilts away from the sun. Sunlight spread over a larger area and days are longer. So for example, this is the Earth and this is the sun. So the sun is away from the Earth is away from the sun. So for example, this is the Earth. So the light is more spread. So the days are shorter. So third is the equinox. Occurs when the sun shines directly at the equator, producing equal day and night hours. So equinox is balance of the equal day and night hours. Lastly is the autumnal equinox is around September 23, and vernal or spring equinox is around March 21 to 20.
Good morning, class. So, by the way, let me allow to introduce myself first. So, I am Miss Monsalad, your subject teacher for today's lesson. And today, we will be able to know about the sun and the earth and moon system. So, specifically, we will tackle about the solar eclipses, phases of the moon, and the tides and the moon. But before that, let's have first a very quick review about the lesson that Mr. Elimino discussed to you earlier. So thus, let's have a question first. So what is the central idea proposed by Nicholas Copernicus about the Earth's movement? So any idea? Yes, precisely. So the central idea proposed by Nicholas Copernicus was all about the Earth and the other planets revolved around the Sun. So and the Earth rotates on its axis. Therefore, since you already gained enough lessons regarding on the last topic, so we will now proceed to the newest topic, so which is the solar eclipses, phases of the moon, and the tides in the moon. Can anyone from the class remember those two types of solar eclipse? Yes? Of course. So we have total solar eclipse and the partial solar eclipse. So the total solar eclipse, so it is when the moon completely blocks the sun's light. So in other hand, the partial solar eclipse, only part of the sun is obscured. So these events are infrequent and brief because the moon's shadow is relatively small compared to the Earth's surface. So first to be discussed is about the solar eclipse. So a solar eclipse happens when the new moon passes directly between the Earth and the Sun, so casting a shadow on Earth. So in other words, a solar eclipse occurs when the moon aligns perfectly between the Earth and the Sun. So this alignment causes the moon to cast a shadow on Earth, so blocking the sun's light. Understood? Okay, so there are two main types of solar eclipse. So any questions, class, before we will proceed to another topic for today? Okay, very good. Thus, Earth's season equinox occurs when the sun shines directly at the equator, so producing equal day and night hours. Autumnal equinox is around September 22 to 23, and vernal or spring around March 21 to 22. So Earth experiences seasons due to its tilted axis as it orbits the sun. An equinox occurs when the sun's rays shine directly on the equator, so resulting in equal day and night lengths all over the world. The autumnal equinox, marking the start of autumn in the northern hemisphere, happens around September 22 to 23. and the vernal equinox, signaling the beginning of spring in the northern hemisphere. So it occurs around March 21 to 22. So moving on to the phases of the moon. So as the moon orbits the Earth every 29.5 days, we see a sequence of phases. And these phases ranging from a completely dark new moon to a fully illuminated full moon. So are determined by the changing angles at which we view the moon's sunlit surface. And as the moon revolves around the Earth, so there are different portions of its surface are illuminated by the sun, so creating the familiar phases we observe. So this continuous change in the moon's appearance is due to its position relative to both the Earth and the sun. In the solar eclipses, a solar eclipse happens when the new moon passes directly between the Earth and the sun, so casting a shadow on Earth. In other words, a solar eclipse is a celestial event where the moon moves between the sun and the Earth, so blocking the sun's light and casting a shadow on Earth. So this can only happen when during a new moon passes, when the moon is in direct alignment with the sun from our perspective. So and as the moon passes in front of the sun, so it creates a temporary darkness or dimming of the daylight. The extent of the eclipse depends on the alignment and distances between the sun, moon, and Earth. So any clarification? Okay, very good. So before we'll jump on to the last discussion, so let me ask one question first. So what happens during an equinox? Yes, so basically, the sun shines directly on the equator, so producing equal day and night hours. Thank you so much. Let's now jump on to our last topic, which is the tides and the moon. The moon's gravitational pull causes tides on Earth, so the sun also produces smaller tidal effects. And when the solar and lunar tides align during new and full moons, we experience spring tides, which have higher than normal tidal ranges. And during the first and last quarter moons, the solar and lunar tides partially cancel out, producing neap tides, which have lower than normal tidal ranges. Furthermore, when the sun, Earth, and Moon align during new and full moons, their combined gravitational pull creates spring tides, which are characterized by unusually high tides and low tides. Conversely, when the moon is in its first or last quarter phase, the sun and moon's gravitational forces are at right angle to each other, resulting in neap tides. And neap tides have a smaller tidal range, meaning high tides and lower tides are higher than usual. So any violent reactions and clarifications? Therefore, to sum up with, Earth rotates on its axis and revolves around the sun, which produces day and night and causes the seasons. Solar and lunar eclipses occur due to the alignment of the sun, Earth, and Moon. The Moon's orbit around Earth causes its phases, visible from Earth. The gravitational interactions between the Moon, Earth, and Sun creates tides, including spring and neap tides. So any questions before we will proceed to our activity? So now for your activity is I want you to explain Earth phenomena through drawings and short explanation. So you need to complete the following task. So number 1 is draw and label the Earth's rotation, Earth's revolution, and tilt phases of the Moon, the solar eclipse or sun, Moon, Earth, in the tides diagram, or spring and neap. Number 2 is you need to give a short explanation. How does the Sun, Earth, Moon system affect life on Earth? I will only give you 20 minutes for that activity. Understand? Okay, so your 20 minutes starts now. Okay, pens up. So good job class for a work well done. And please pass the works or your papers if that. And now, I want you to get a 1/4 sheet of paper for your assessment. And I will only give you 15 minutes to answer the assessment. You may start now. Okay, time's up. So pass your papers forward, class. Very good. Thus, I want you to all know that the universe is in motion. And so far, we keep exploring. Thank you so much for your cooperation, class, and have a productive day ahead. Make a simple infographic showing one concept: seasons, day or night, eclipses, phases, or tides, and your infographic should clearly explain the concept in your own words. So include labels, symbols, or small diagrams to make it easy to understand. And show that you fully understand and can apply the concept. Any questions and clarifications? Thank you so much for your cooperation, class, and have a productive day ahead.